Hey guys, so today is the first video for Unit 2 and we are moving on to what is called matrix operations. So a matrix, as we're going to define it down here, it's a rectangular arrangement of numbers in rows and columns. The dimensions are also rows by columns. Rows run left to right, columns run up and down. And it's written as m by n, or m times n. The elements of a matrix are each individual number of the matrix. So let me just do a simple 1, 2, 3, 4 over here. So this is a 2, because we have row 1, row 2, C1, C2. This is a 2 by 2 matrix, okay? And each of these numbers inside of the braces, 1, 2, 3, and 4, those are all elements of the matrix. An equal matrices, which is the plural form, so multiple matrix, has the same dimensions and corresponding elements that are identical. So if we look here at example 1, for A, well, this is our row 1, column 1 element, and this is our row 1, column 1 element on the other side. 2.5 is the same as 5/2, so technically that is equal. -1 and -1, those are the same. -0.2 and -1/5. Well, if you type -1/5 in your calculator, those are going to match up. And then 3 and 3, so yes, these are equal because all of the elements match up. Now, if we look at part B, those are two completely different matrices. None of the elements match up, so this is not equal. Okay. Now, we can do all different kinds of operations with matrices, and you're probably thinking, well, what's the point of this? Matrices are used to do a lot of large calculations in a short period of time. So a lot of computer programming is based off of matrix operations because it can be performed very quickly. So that is why, and this is like the introduction to that. So perform the indicated operation if possible. You can only add or subtract matrices if they have the exact same dimensions. So for this one, this is a 3 by 1, and this is a 3 by 1. Okay, so that's perfect. 3 rows, 1 column. And the reason is because we are actually just adding the corresponding elements. So 0 plus 1 gives us 1 for our final matrix. And then we do 4 plus -9, which is -5. And then we do 3 plus 8, which is 11. And there's our answer to part A. Part B, again, we need the exact same sized matrix to add. So this is a 2 by 2, and this is also a 2 by 2. So we can go ahead and we can subtract these. So basically what I'm doing is 3 minus 2, which gives us 1. Then I'm doing 3 minus 0, which gives us 3. 9 minus a -3. So I'm just going to write that here for a second. I'm not completely done with that. And then -5 minus 5. So nothing changes for the top elements. That's still going to be 1 and 3. But when I do 9 minus a -3, that becomes +3, which is 12. And then the other side becomes minus 10. So here's our answer for part B. Now C, if you look at the first matrix, it's a 1 by 2, and the other side is a 2 by 2. Since the dimensions don't match up, it's not possible to add those two together. So not possible because of their different dimensions. So it's very important that you know how to read the dimensions of a matrix in order to do this whole unit. Next, we're going to talk about scalar multiplication. So a scalar multiplier is just something that's going to affect every single element. So basically it's like the distributive property. So this 6 is going to multiply to everything inside of the matrix. So 6 times 2 is 12, 6 times negative 3 is negative 18, 6 times 8 is 48, and then 6 times 4 is 24. Notice we still end with the exact same dimensions as what we started with. Everything is just 6 times bigger. For part B, there's only one scalar multiplier on the left matrix, but we have to follow the order of operations still. So what you would do first is you would multiply the scalar and then you would add the other matrix to it. So what this is going to equal, everything is just going to become the negative version, because when you distribute -1, you get -4, -3, -2, +7, -3, and +9. Now we're just going to go ahead and add those with the other matrix. So -4 adds to +3, and we get -1. Then 7 adds to 6, gives us 13. -3 plus 9 gives us 6. Then this -3 plus -8, that's going to be -11. -2 plus 1 gives us -1. And then 9 plus -4 is -5. Okay, continuing on. We can also solve for variables within a matrix, depending on how it's set up. So this one wants us to solve for x and y. First thing that we need to do is actually, we would add the inside. So for this one, we would get 4 on the outside. And then the inside, we would get 8 plus 4, which is 12. 0 plus -2x, which gives us -2x. And then -1 plus 1 is 0. And then 2y plus 6 is going to remain the same as 2y plus 6. And then the right side, that's just what it equals. So nothing changes over there. We just know that it has to equal out to these specific elements. So now I'm going to distribute the 4. So I'm going to get 48. The bottom is going to be 0. The next right here is going to be -8x. And then this is going to be 8y plus 24, because we got to distribute it to both parts. And then the other side is 48, 0, -48, and 8. So it's important to note that these are equal matrices, because that means that each element has to be the same. So if -8x is equal to the other side, then it has to equal -48, and that's going to help us solve for x. I'm going to divide by -8, divide by -8, and I get x equals +6. Exact same idea with the other variable, y. Down here, 8y has to be, or 8y plus 24 has to be equal to 8. So I'm going to subtract 24, subtract 24. I get 8y equals -16. Divide by 8. Y is -2. There's my answers right there. So what I had to do first was I added the inner matrix on the left side, added up all the corresponding elements, and then I distributed the 4, and then I set it equal to the right side matrix, and then just solve for x and y. Okay, so for example 5, now we get a word problem. The matrices show the number of hardcover volumes sold and the average price per volume in dollars for different subject areas. So we have 1995 as our matrix A, and then 1996 as our matrix B. It wants us to calculate B minus A. So we have to go in that order where B comes first. And then how many more or fewer law volumes were sold than in 1996 than 1995, and then it's got another question after. So let's start with B minus A. So I'm going to line this up So B is 1 0 7 0 0 0 0 8 2 7 0 0 0. This is a 4 by 2 matrix. And then we have 53.40, 88.51, 39.21, and 33.92. Minus, now we got the other side. You don't necessarily have to write these all out. I'm doing this just to show you. And the other matrix is also a 4 by 2, so it's okay that we subtract. Okay, so we would subtract these, and then we are going to get our answers here, and